Every harvest season, a thick gray haze settles over Delhi, as farmers across northern India set millions of tons of wheat straw on fire. At times, the city's air pollution can soar to more than 20 times the World Health Organization's recommended limit. Yet ironically, the very straw being burned contains enough cellulose to become toilet paper. If agricultural waste can become toilet paper, why does the paper industry keep cutting down millions of trees? The answer lies inside a modern factory, where rough straw is transformed into the toilet paper we use every day. Everything begins in a wheat field in Washington state, one of North America's largest wheat-growing regions. After a combine harvester separates the grain, the remaining stalks are compressed into large round bales, weighing around half a ton each, scattered across the fields. Within a 100-mile of a mill like Columbia Pulp, farmers produce roughly 4 million tons of wheat straw every year. Most of it was once burned in the fields before the mill opened. The bales are collected, loaded onto trucks, and transported to the mill. Once they arrive, the straw is fed into an industrial shredder, where it's chopped into pieces just a few centimeters long. At this stage, it still looks exactly as it did in the field, dry, stiff, and covered in dust, with nothing to suggest it's about to become something as soft as toilet paper. The real transformation begins here. The chopped straw is fed into massive digesters where it's cooked in a sodium hydroxide solution at temperatures of around 300 to 320 degrees Fahrenheit under high pressure for several hours. The sodium hydroxide doesn't dissolve the cellulose. Instead, it breaks down lignin, the natural glue that holds cellulose fibers together. As the lignin dissolves, the fibers separate into a thick slurry known as pulp. This is the defining step of the entire process. Without it, wheat straw would remain nothing more than wheat straw. The pulp is then washed repeatedly to remove the remaining black liquor before passing through a series of screens that filter out any straw fragments that haven't fully broken down. Next comes bleaching. The goal isn't to make the paper safer, it's to remove the last traces of lignin and brighten the pulp, creating the clean white appearance consumers expect from a roll of toilet paper. The bleached pulp is refined to soften the fibers, then mixed with water until more than 99% of the mixture is water, with cellulose making up only a tiny fraction. That dilute slurry is spread across a continuously moving wire screen, where the water drains away, leaving behind a thin web of interlocked fibers. The sheet is then pressed against a giant heated cylinder known as a Yankee dryer. A steel blade scrapes the paper from its surface in a process called creeping. This single step gives toilet paper its signature softness, bulk, and absorbency, instead of the smooth, dense surface you'd expect from printing paper. The enormous paper roll is finally rewound, cut into smaller rolls, and packaged into the toilet paper found in bathrooms around the world. At this point, everything seems to make perfect sense. Wheat straw can become paper. It's an abundant agricultural byproduct, and using it doesn't require cutting down trees. In fact, many engineers once believed this could be the future of the paper industry. So why didn't it happen? The answer lies in something so small that most people never notice it: silica, a naturally occurring mineral that wheat plants absorb from the soil, with the highest concentrations found in their leaves. Wood contains very little silica. Wheat straw doesn't. During the pulping process, much of that silica dissolves into the black liquor. the liquid left behind after the fibers are cooked. When the black liquor is concentrated so the chemicals can be recovered and reused, the silica precipitates back out, coating equipment, clogging evaporators, and forming stubborn deposits inside the recovery boiler. Eventually, the entire recovery system has to be shut down for cleaning. Every hour of downtime can cost a mill anywhere from $20,000 to $100,000. But the biggest consequence isn't the maintenance bill. Silica has quietly placed a ceiling on the entire industry. Most non-wood pulp mills operate at only 60 to 70 tons per day, while a modern wood pulp mill can process thousands of tons over the same period. Wheat straw doesn't lose to wood because it lacks cellulose. It loses because one tiny ingredient has kept it from scaling up. If one country has proven that wheat straw can be used to make paper on an industrial scale, it's China. The technology dates back more than 1,000 years to the Song dynasty for one simple reason. The country had limited forest resources, but an abundant supply of agricultural straw. At one point, more than half of the world's non-wood pulp was produced in China. But even a country that had worked with straw for centuries couldn't escape the silica problem. Beginning in 1996, as part of a nationwide effort to reduce water pollution, the Chinese government shut down roughly 7,000 small paper mills, most of them relying on non-wood raw materials such as wheat and rice straw. As a result, China's non-wood pulp production fell from more than 22 million tons in 1995 to less than 6 million tons 2 decades later. The industry gradually shifted toward large-scale wood pulp mills and recycled paper, which offered more consistent quality, cleaner production, and fewer technical challenges than straw. The very material that had once helped a wood-poor nation build its paper industry was eventually left behind by the country's own economic and industrial development. The idea didn't stop in Asia. Across North America, a handful of companies have also tried to make paper without cutting down trees, but for a very different reason than China. In Canada, Prairie Pulp and Paper produces a paper made from 80% wheat straw, a product compelling enough to attract two-time Oscar nominee Woody Harrelson as its public face. Harrelson has even described making paper from trees as barbaric. The involvement of a Hollywood star reflected the excitement surrounding tree-free paper and the confidence it inspired among investors. But running a business turned out to be far more difficult than promoting an idea. In Washington state, the similar Columbia Pulp project spent 4 years securing enough funding before construction could even begin. And it wasn't alone. A number of smaller tree-free paper mills eventually disappeared under the pressure of industry consolidation and intense market competition. The problem wasn't that the idea lacked environmental benefits. The problem was that the market doesn't reward a product simply because it's better for the planet, if it still can't compete on cost. By now, the question is no longer whether wheat straw can be turned into paper. The real question is whether making paper from straw is actually cheaper than making it from wood. Wheat straw is a low-value material, but it isn't free. Farmers can sell it, use it as livestock feed, mulch, or even grow mushrooms on it. And turning hundreds of thousands of tons of scattered straw into a steady supply of raw material is expensive. It has to be collected, baled, stored, and transported, sometimes over hundreds of miles. Wood, by comparison, comes from concentrated plantation forests that can be harvested year-round. Straw is seasonal, and long-term storage brings additional challenges like moisture, mold, and fire risk. Then there's the silica problem we explored earlier. Dealing with it requires more complex processing and adds to the cost of building and operating a mill. In some cases, a straw pulp mill can cost as much as, or even more than, a conventional wood pulp mill. In other words, the paper industry didn't choose wood because it makes inferior paper. It chose wood because the entire economic system, from supply chains to mill design, has been optimized around it for more than a century. That's why most straw-to-paper projects around the world remain relatively small or continue to rely on environmental incentives and government support rather than competing on cost alone. In the end, the answer has never been about technology. Wheat straw was being turned into paper more than 1,000 years ago, and it's still being used to produce paper on an industrial scale today. What has kept it from replacing wood isn't science, it's economics. The cost of collecting straw, the challenge of silica, and an industry whose infrastructure has been built around wood for more than a century. So the next time you see smoke rising from a field after harvest, you may not see agricultural waste anymore. You may see a raw material with the potential to become something entirely different. The real question is whether that potential will finally become practical. As technologies like biopulping become more affordable and the pressure to reduce deforestation continues to grow, will the economics of paper finally begin to change? Or will wheat straw remain what it has been for centuries, a promising alternative, but never quite enough to replace wood?